Good afternoon. Can everyone hear me? Everyone awake? Had a good lunch? Good. Just want to start off, housekeeping as usual, just a reminder to everyone to turn your cell phone off. We don't want any disruptions. Make sure to fill out your survey for the sessions, and particularly for this one. We will have Q&A. Just wait till the end. We'll leave plenty of time for Q&A. And I'm going to introduce Matthew Jacobson and Brent Perry from the U.S. Air Force Research Lab.
On loan.
Yeah. Honorary member here.
Go ahead and take it away.
Okay, thank you. My name is Matt Jacobson, and I am with the Air Force Research Lab out of Wright-Patterson Air Force Base in Dayton, Ohio. And my role there is as a software engineering team lead. And what we're going to walk through today is a journey. Less answers, more questions, but hopefully there will be at least solidarity. You'll empathize with some of the things we're going through. It'll prompt more questions, more good discussion, and we sure have learned a lot, so I'm excited to share that with you. So a little bit about us. We are, for the Air Force, the principal generator of material data for processing, for characteristics, and this feeds a huge array of applications: structural engineering, biology, everything in between. Anywhere where you're going to see an application of a weapon system or any particular technology in the Air Force, and it involves materials, we're probably responsible for where that data comes from. So in addition to a wide array of applications of materials, we also have a wide array of materials themselves. We have biomaterials, ceramics, metals, composites, everything in between. And this starts to get into a little bit of our problem space that I'll talk to more specifically in the coming slides. But to give you an example of the kind of data that we face and that we generate, about 20 years ago there were approximately 80 metal alloys that were widely used in industry and inside the defense space. Today there are over 1.5 million. And our traditional methods of experimentation are not sufficient to give us the fidelity of data that we need, the quality of data that we need to feed those downstream consumers of the information. Again, structural engineering, manufacturing, sustainment. So we are also the lab that, for example, when a rotor fails in a turbine engine, they will send that part to us and we'll try to figure out what went wrong. So this starts to, again, talk a little bit about what some of our desirements are. And you'll hear me talk a lot about pedigree. And pedigree. That's one of our big themes. I think this morning that was one of the things that David had talked about was pedigree, understanding the relationships between data. So those are all the things that we're looking for inside of our lab. Just this little slice of the Air Force Research Lab, we are one component of several. There are about 10,000 people in the Air Force Research Lab. We have just under 1,000 presently. But you can see that the parameter space here is quite large. And what's tricky from a software engineering perspective is that every one of those, in this case 700 scientists and engineers, has a unique use case. So one of the things that we found early on is that it was ineffective to develop solutions for one specific part of the community. What we had to do was build solutions that were scalable, where we could achieve a development economy of scale, make things flexible. And this really kind of paved the way for us to get into the NoSQL and specifically the MarkLogic space. So I think we can accept that a lot of this is true based on all of our combined experiences, but for us, that first one under volume, the timing was pretty good on this story. I talked to a gentleman recently from the High Performance Computing Center who does fluid dynamic simulations for ducting at Mach 6. And as a result of that, running these simulations on 100,000 cores for a month, he can generate an exabyte of data in 1 month, one person, one simulation. And so in addition to the volume then, the level of fidelity that we need is tremendous, right? We want to understand fluid behaviors, for example, at that exabyte quantity, and it just becomes unmanageable very quickly. Additionally, of course, we want to access our data faster, and we want to understand it more, while at the same time trying to contend with the fact that our variety increases. So we need a multi-model representation of the data that allows us to span organizational disparity and also varying complexity within those different parts of that multi-model. So we need a highly flexible source. Furthermore, when we talk a little bit about our failure modes, that there's no overarching governance model. This is a research community. These are very, very intelligent, empowered people. And when left to their own devices, they come up with all different ways to store their data. Some good formats, some poor, mostly poor. And then we're left to try to contend with that. Further, the software tools that we build, of course, in the DoD, were far worse than industry as far as those failure rates that, like David was talking about this morning, ours are north of 90%. And a lot of that has to do with our mentality. We don't have a data-first mentality. We don't think about data. And I'll be honest with you guys, that's one of the hardest things that I've found in my role, is that this really isn't a technology problem. Aaron Rosenbaum and I were talking over lunch about this, about needing to have an economy that drives this. We need to have funding, we need to have policy. It's a combination of all these things, but we also need to have culture. And so that's one of the things that we're struggling with mightily, that I'd be interested in sharing some stories with you guys, maybe off the program here. At the end of the day, what we're trying to get to, I referred to earlier that our experimental methods are not sufficient. And by that I mean trial and error cannot work as the volume of material complexity and data goes up. We have to get smart about doing model-driven research. We have to have good microstructure models, behavioral models, physics-based models that we can use to determine the best way forward in materials. For that 1.5 million metal alloys, we clearly can't test every one of them and pull on them and see how they behave. We have to start gathering better data. And so, again, we'll talk a little bit about how we're tackling that. And that really, having said all that, this was kind of the intro that we gave Brent a few years back. And so for the benefit of you guys who are seeing this for the first time, I'd like Brent to give you an idea of what his first impressions were.
Right, so Matt has, I guess I'll let you all decide whether it was a wise decision or not, but he's asked me to step up here for a minute and give you my perspective on Matt, on his team and the organization engaging in this use case. So I've been with MarkLogic for just over 4 years now, and Matt was actually the very first technical call that I was on, right when I joined the company. That's how long we've been working together. And Matt just did a really nice job of walking through and describing this storm of data that he exists in. And lucky for his team and his larger organization, he's actually a really good captain when it comes to navigating that storm. All right, and as he was saying, part of their issue is not just technical, but it's really cultural. Right, so it's about finding the funding, getting the endorsement, getting the support, getting the engagement from the user base. It's challenging. And that challenge has driven them to have to approach this problem from a different angle. So in my experience, certainly before MarkLogic as well, a typical approach to solving users' problems with software or with systems was to assess the domain, right? Take a look at all the requirements, take a look at their consumption use case, right? How are they going to access this data and use this data? And then design an ontology, design a system that was going to speak in the language they wanted to speak. And that sort of drove those system requirements, and that trickles down to the user experience and how they access the system. But Matt doesn't have that luxury. He's sitting on top of a user base that's extremely diverse, and not even all at AFRL, right? It's the material science community at large that he's engaging. And that means the solution coming out of the team has really been to drive from the bottom up, to give them the tools so that they can actually define the vernacular they want to use for their domain in their own terms, and let them build their own data models, let them build their own ontologies to communicate amongst themselves. And it's a new way of approaching things, and MarkLogic's flexibility has given them the opportunity to move forward with that. So as Matt was saying, there's some tremendous data challenges, but with those challenges come a ton of opportunity. So I've had very long discussions with Matt where he's talked about the nearly physical pain it induces to see the inefficiencies, right? Whole teams that are stood up with some of the brightest minds working with raw samples, putting them through testing processes, finding knowledge, right, from that test. They learn something from that test, and then it goes into a drawer, or that person retires and it falls on the floor. And just 6 months later, a whole new line of funding is required to get another team in order so that they can take that another step. And that inefficiency, not being able to share that knowledge across those operations causes a good bit of angst and a lot of wasted money. So Matt has had the vision to see the opportunity there, right? How can we actually capture this knowledge? How can we hold on to it? How can we trace the pedigree that comes with it so people can decide for themselves the applicability to their own use case? So what are some of the ingredients for success, right? We've had some really good successes as a team. First and foremost is probably the somewhat absurd relationship that Matt and I have developed over 4 years. He's a brother from another mother, if you will. So I get texts on weekends when he has ideas. We spent countless hours at whiteboards working through ideas. And really it comes down to a shared passion for trying to get these ideas out of his head and my head to the whiteboard, from the whiteboard to like a backlog of tasks, right? That turns into a development plan, sprint schedules, integration test milestones, deployment, testing, and user acceptance, right? So it's getting those ideas from our minds to execution and deployment and success. So we have a lot of shared interest in that regard. But how do we actually do that? Well, we're in agreement that the goal here is to get a data management system in place for the research users, the research community. And Matt has already described some of the challenges that user base presents. But we very clearly have walked right into an operational data hub scenario. Why? Well, because his team, as well as the nature of the domain, demand agility, right? So yes, there, of course, as was spoken about this morning, there's a need for agile software development. They're working in sprints. There's user stories being talked about, rapid turnaround deployments, but it's also about agility in the face of a volatile workspace of data, right? So emerging data sources that can very quickly take you from a gig to a terabyte or a terabyte to 100 or more. So, and high flexibility, the need to not just respond to those changing data sources, but scale up with them, and scale up with them without actually tearing down the whole system and rebuilding it from the ground up just because a new data source emerged. The other thing that Matt and his team like to do, should I call it a hobby? No, maybe not, but they tackle these libraries, right? So I've got a need. I need to be able to visualize something that looks like analytics. Do I want to use Plotly? Do I want to use HighCharts? Do I want to use this other tool? There's a need to evaluate these different capabilities to assess whether this is something they want to roll their own or if they want to use something that they're seeing a lot in use in industry. The platform is giving them open standard interfaces to do that. They plug into it, they test it out, they try it, they decide to roll their own or they don't. There are many cases where the data is owned and governed by remote systems, and he's got to use the HyperThought system to reach out and grab that information, bring it into MarkLogic, index it, make it searchable. In addition to that, the last point there is, again, we're going to double down on it, and Matt's going to talk more about it in a minute, but it's this absolutely critical need for the community to drive this model-based domain definition, right? The language by which that they all need to speak to each other, and the system needs to be flexible enough to handle that. So I'll hand this back to Matt so he can walk us through his conclusions.
Okay. So as I said before, one of the first exercises we did was sort of classical, traditional software engineering approach to say, take the consumption use case. What are you concerned with in this particular data set? How do you intend to consume it? Now let's roll this back and say, what is the process? Let's build a great big sprawling process map. How do you arrive at the point where you want to consume the data? And then what pieces in that process generate the data that will feed that set of queries at the end? And so we were using SQL before, and we were using a Python framework called Django to deliver basically web digital collection forms to the community to say, we want to replace your paper notebooks. And I can't stress how big a thing paper really is with AFRL. I mean, we rock that stuff. So we want to replace that, but as I said, and I said this earlier, it just doesn't work from an economy of scale. The next lab we go to, it's a completely different set of use cases. So then we'll run to the next room, we'll do the same thing for them, and then we'll go back a couple months later, and that first use case has changed. I mean, that's the nature of research, right? So we said we have to have a more flexible data model. And not just a flexible data model, but we need to be able to support the multi-model context to use the right type of expression of the data elements themselves in the right circumstances. So we use this one listed there, Mongo. I really
Waiting
want
for the dramatic reaction. Just waiting for me to
I wanted
flip
to wear my
tables.
Mongo shirt just to torque Brent off today. That's how we troll MarkLogic. But no. And like you said, we need to be able to make these make-buy decisions, and actually MarkLogic was really the first push for us to move into the commercial space, away from these early prototypes that we developed ourselves. And David was saying this morning, the data, you can do so much with the database, and so that's why we focused early on saying, let's change the shape of how we describe these concepts. Furthermore, not only do we need flexibility and economy of scale, but so do our users. I cannot afford to become a minified expert in metals or ceramics. I have to let the users define those domains. And for any of you, this may result in like some sort of fisticuffs thing, and you're welcome. You know, we'll take all comers. We're going to have to fight about the ontologies piece here. There are I'm very much at odds with some members of the ontology community. I'll just put that out there. And we're proud of where we've gotten, which is to say that we do not take the approach of a authoritative, monolithic dictionary, vocabulary, taxonomy, ontology that we then put on the users. We have seen community after community do this, and it fails. Now, ours does look a little bit more Wild West, and to the purists, they lose sleep over it. I'm okay with that. They'll come around, hopefully, and hopefully we have to be successful, and then they can come around. But we've seen some huge benefit from doing this. So anyway, we use Mongo early on to do this, but there's just so much we can't do with that, like baked-in search, like semantics, right? True RDF expression of our data models and retrieval. We can't do that. So this is one of the reasons why MarkLogic was kind of a no-brainer for us early on. In addition to the fact that we've had such a great technical partnership, Brent and I, and our team and his team, just working at the whiteboard and saying, how can we do this? And we keep seeing, like even today, just before lunch, we were at the whiteboard again down in the developers lounge, hashing through the next set of things coming down the pipe. So what we have to provide then is, in addition to allowing these model-based definitions to rule the day, we have to give people this operational data hub that allow them to access data that are held corporately in our organization, but also in the rest of the organizations that represent those other 9,000 researchers, as well as data that are held by organizations all over the United States and all over the world. We simply will not be able to aggregate all the data internally to our own MarkLogic instance, so we have to be flexible. So down here, just to drop some performance metrics. We did a little bit of this. We saw early benefit in moving into a MarkLogic solution by seeing a 100-fold increase in our performance by co-locating data from SQL into MarkLogic. So that is an extremely viable solution for us because we do a lot of work with the aerospace OEM community, and they send us data in all kinds of formats. And one of the very popular formats is these big sprawling SQL databases. And so one of the first things we do then is we co-locate it in MarkLogic, make it searchable, and then allow people to go back and get the records. But enormous increase for anybody that's looking for some metrics to take back home. That is something that we've proven time and time again, is that works to vastly increase our performance. So I've covered a lot of this, but for us, this is the starting point for dealing with the complexity, the multi-model demands, for dealing with the ability to do complex parameterized searches, and for us to support native RDF so that we can do those domain-based definitions. In addition to the fact that, as I said before, those models change all the time. And so whereas before we were doing runtime SQL migrations in Django, now we can just accept the data as it comes in, hold it in residence, and we see a lot of benefit there. Now, as any technology decision maker will understand, you have to be able to justify that kind of, even a 100-fold increase in performance is great, but for us right now, it's about trying to maintain, it's just not feasible for us to maintain the open source side of the house any longer. And I'd be happy to go into more detail after this presentation as to what that means. We have a relationship with academia, a very, very strong relationship with academia, and we like to go to them and say, here's how we would propose that you do this. But a lot of them cannot afford the commercial solutions that we've baked into our technology stack. And so as a result, we try our best, but generally are not able to keep up with the pace of what MarkLogic has in terms of the feature set. So ultimately what we've done by going with MarkLogic in this case is we've saved tens of thousands of hours, or probably more, however much time they've put into these capabilities. So we've talked a little bit about this, but what I started doing 4 years ago was I built this technology stack with my team called Hyperthought, which was meant to represent an integration of capabilities. Rather than trying to be a monolithic sole source for all things for all people, we said we would integrate what we've learned using an API first design mentality with a flexible data model. And as I said before then, MarkLogic became a very important part of that. So we give our users the ability to connect systems from all over the place, to apply data models to those, to describe what they're doing, to describe the data coming in from these other data sources. And we give them a really rich user experience that's very visually driven. I'll show you a little bit what that looks like. But ultimately, and this is one of the key takeaways here, if you're in the business of doing anything like this, it's to stay very close to the data consumer. We've heard a lot about the consumption use case. What is the consumption use case? To sit really close to the end user. You cannot interact with them enough to do that and really understand what that joint effort looks like between the experts and the solution providers. So right in there, I don't actually have the MarkLogic logo. Sorry, I promised I would put that in there, but that's where it goes, right there in that middle layer. Trust me, just trust me, it's right there. MarkLogic and Hyperthought give us access to all these disparate systems and resources, but it of course gives us the ability to put really high performance in-residence data inside MarkLogic proper, and to connect with other systems and services. But then in addition to that, that's all transparent to the user. What they want is a single source where they can go in and say, I want to know about titanium. We give them everything back. It was just a discussion. One of my objectives is to see how many times a day I can get Brent to right there, that's it. That's it. Shake his head and face palm. How can we basically do dynamic faceting, or something that looks like dynamic faceting, to satisfy the need to be able to reach out at runtime, grab data, pull it in, and aggregate it with highly indexed, highly faceted stuff without losing track of it. So what we want to do is not let our users have to be troubled with all the different things they're connecting to. So we've given them a user experience that gives them all these functionalities you see here, including the ability to define those data models. This is pretty much a wrap-up of what I just said, but one of the cool parts about having a flexible multi-model definition capability is that it can be applied across different domains. So we have the ultimate flexibility when we found we could, hey, we can define metals, we can define composites, we can define munitions. Now we can define other aspects that are involved in biology, chemistry, high-performance computing, medicine. This is all driven by the users. So we've talked about pedigree, and this will all come together, I promise, as we wrap this up. And if it doesn't, you guys can shake your heads and I'll try again. But we've gotten the community to agree that what they really want is a visualized knowledge graph. We saw some of that this morning, this idea of pedigree. Now we've chosen to use, the fight goes on between Cytoscape and Viz.js. You guys, what we saw this morning in that great presentation was Viz.js. We're currently using Cytoscape because we don't have to, it accepts graph theory logic directly against it. We don't have to tell it how to execute those algorithms. So this is what we're basically saying. The user wants to say, show me everything that's acted on this specimen that I'm holding in my hand. And there are a lot of reasons why people do that. And it doesn't have to be super complex. I assure you this happens all the time. I've seen it where a world-class expert in metals will pick up a sample off their desk and go, I know I worked on this like 3 months ago, but I have no idea who gave it to me, where it's from. I think it cost like $10 million. So I apologize to all of us taxpayers in the room. It's not great that we're doing that, but we're trying to fix it. It also could be a little more complex, where we're doing an analysis of this part and we see something at the microstructural level that is anomalous. We want to know what the fabrication parameters were. What was it that acted on this part that gave it these behaviors? Right now, that's months of effort, if you can even do it. So when we've shown this to our users, they get very, very excited about the ability to say, these blue nodes are all the different primary elements. This is where it was built. This is where it was cut up. This is where we did microscopy, heat treatment. Furthermore, I can say, well, here's the heat treatment furnace. There's the calibration data for it. So we can see all that stuff. So we've gotten users to accept this is what they want. This is pedigree for us. And it continues to excite and say, this is really great stuff. Now we'll get into how we get there. That's a little bit tricky. Or we may want to do data discovery via searching for attributes. We don't know what we want yet. I don't have a sample I'm looking for the right material to use in the right application. So what I want to do is be able to say, enter some parameterized search, get my results, and then again, visualize what we know about that thing.
We're actually migrating this capability to MarkLogic right now. There was some prototypes that Matt and his team put together that you're looking at, and that first cut was really a static representation of that linked graph, right? Just showing the flat view, all the relationships, the steps, that the interactions between the samples, the processes that were placed upon them, and the resulting products. And what we're moving towards now is exercising MarkLogic's full search, so that people can come in and search for specific pieces of equipment, specific samples, use our standard full text search kind of Googleese-like language, right? So this piece of equipment and this sample ID or this process, pull out sets of entities and automatically bring back their nearest neighbors in these graphs, allowing users to explore those graphs node at a time and extend their view. So they get a broader but controlled view of the relationships between all of the steps, basically, that are taking place on these entities.
Well, and so it's an interesting point, too, that this morning when we were looking at that bit of JSON that David had up on the PowerPoint slide and started to draw out the relationships, the different predicates, is has and all of that. And I think that we've found that it's easy to take for granted what that looks like in this form. Getting that defined is not trivial at all. And so I'm excited to see where we go with being able to infer that type of information, be able to bootstrap basically those and inference those types of relationships and those types of entity behaviors. We're not there yet. So in order to get to number 3, which is where we want to be able to have a highly visual driven user experience that lets people see that pedigree, drill down, search, etc. If 3 is our goal, then at least for the near term, somebody has to give us those links, right? So this, again, we're not especially with the complexity of our data set, this is additive manufacturing as an example. That may have 1,200 different properties of varying degrees of complexity. We're not at the point where we can just go and automatically generate this. So what we have to do is somewhere those edges have to be defined and provided by the user in a way that makes sense to them. I've made the terrible, terrible mistake of subjecting materials researchers to ontology discussions and the philosophy, and then they just lose their minds. They're out pasturing somewhere, we've lost them, so they can no longer be counted amongst us. I mean, it was worth it, I think. They were pioneers, and we respect their sacrifice. But we try not to do that as much again. So one of the things we learned there is rather than trying to teach people to have a model-centric view of their domains, we give them tools to do it that makes sense. So we have to be able to supply links, which means we need a tool for doing that. Now, one of the things that happens, as I said earlier, if an additive manufacturing process has 1,200 attributes, we have to give them a way to define those in a reusable way so that at runtime they're not constantly having to remind us what those attributes are. So we need to have the ability to create user-defined data models. We've talked about this already a couple of times. So here's what that looks like. Again, it's a similar interface that we've used before. It's called Cytoscape. I think Viz.js will win the day, but that depends on us going back and roughing some people up on the team. We'll do our best. We'll have a full report on the next MarkLogic World. So it's basically to say, here's my mechanical test, and here are all the constituent elements, including the relationships. We started with simple predicates, HAZA. That's been one of our challenges, though, is to define how many of those we offer to the user to use. But in this case, now we have an authoritative canonical model for what mechanical test should be, and it's reusable. This is shareable. And MarkLogic gives us the ability to define this and store this as native RDF and implementing what's known as SCOS. So we're using SCOS to define these models. And again, to the mechanical engineer, they don't have to worry about what that underlying data structure looks like. All they have to do is drag the nodes onto the canvas, connect them with lines, and tell us what those relationships mean. And so we've had a lot of early success with this and giving us these reusable models. So now step 1 is met. Then we give them a graphical canvas for dragging highly abstract processes onto this canvas and then associating those with data models. This is my mechanical test right there. I've already created the model for it, so what the user can do is go into that over here and pick who it's supposed to go to, what this thing is. So they can go from an extremely high level of abstraction and then immediately assign it with these atomic level data models, and now they have full fidelity into the process. This canvas oftentimes will contain thousands of elements. Depending on the complexity of the process, we can support all of that. Again, it has to be highly flexible, and that's, yet again, one of the reasons why MarkLogic has been so important to us. And then ultimately, this is what that kind of looks like, where we can visualize these sprawling research results and pedigrees that span different organizations. So where we are right now, again, the discussions we've even had today are how do we take data that we're getting from external sources and then attribute those to our domain data models that we have established. So we have a relationship with, like Lawrence Livermore National Lab, for example. We got some people in the house here. What's up, guys? And how do we understand what we're getting from them? We're not going to acquire their data. They're not going to acquire our data. So what we're going to try to do is use these schemas to help seal that communication to define what we're actually talking about. So we've talked a lot about all this already, but for us, preventing redundancy, because here's the thing, the use case earlier where that confused mechanical tester picks up the sample, if they can't find it and they get too fatigued, they'll just put it down and forget about it, and then they'll do it again in a month, and it'll cost $10 million. This happens a lot. But they don't have the tools. So I'm not trying to just take unfair pot shots at the research community. They don't have the right tools to manage this stuff. So preventing redundancy is huge. That costs us a tremendous amount of money. That leads into optimizing our research resources. But also, it's very uncommon for us to do things only in-house. The national labs are a good example, where they will oftentimes do material studies that span Los Alamos, Livermore, Sandia, and Oak Ridge. They'll all work together. My best understanding is right now, SharePoint is what they're using to collaborate on data. We can do a lot better than that. So that's one of the things we're trying to do is establish ways, again, to use those shareable schemas, those portable schemas, to help define the contents. All of this for us is driven by really this acronym FAIR: findable, accessible, interoperable, and ultimately reusable. We want the data to be reusable, and so we have to step through making it findable, making it accessible, interoperable, and reusable. And I don't think, especially after this morning's keynote, that I need to go into why element level definition for who can access it, what this thing is, where it's been used is so important for that reusability to actually be a thing. So we're very excited about the potential there. This drives a lot of our data management policy and governance. So it's a really big deal. Where we are right now, the two big use cases that we're tackling are with the additive community, as I mentioned before. So what we're trying to do is basically submit data that we've generated and processing. This could be up to 100 terabytes at a time, up to a public-facing website where people can accept the challenge that we've issued out, which is to say, tell us everything you can figure out about our data, because we don't have the resources to do it ourselves. And there's a cash prize at the end. And it works really well. So the academic community will get involved. Other industrial components will get involved. And so the thing about it is we have no idea what we're going to get back. So we have to be able to accept and accommodate those rapidly changing dynamic structures. And it's in high volume stuff. I mentioned earlier that we've seen data sets as large as an exabyte coming out of simulation. But this stuff too, the way they monitor additive builds, you can easily generate a terabyte of data inside of a 10-minute run. And so we're going to have to take account for that. And then what they're going to want to do is, as I said before, they want to be able to do model-based definition. So what you really want is a complete 3D representation of that sample, the microstructure of that sample, that you can then interrogate and perform further research on. So that's that veracity. We have to have atomic level fidelity. And so in discussions with the project manager leading that, they've said that we simply couldn't do this without the capabilities that are being brought to bear by Hyperthought and MarkLogic. Additionally, and this will make the taxpayer really happy, I hope, is that we do have up to 40 years right now of test data that's sitting in filing cabinets in rooms that are larger than this. Hundreds of filing cabinets that contain data. It's critical because these are in-service weapon systems. So what we're doing, it's not super crazy complex, but we're scanning all that data in, doing an OCR exercise on it, indexing and fasting it, and making it searchable. We're saving thousands and thousands of hours of time in our community by doing this. And just these components alone are worth more than $2.5 billion. That's a conservative estimate on my part based on the number of components that are in service right now And so it's kind of a foregone conclusion there. The testimonial that you see at the end that says any way that we can take this data gathering exercise and make this available to the community is a game changer, and how we do not just sustainment on these things, but also how we do predictive modeling and say, how do these materials behave? How will they behave in 10 years, making it digital? So it's kind of a stream of consciousness, kind of walking through this. It's been a very, very fun journey. There's never a moment of rest in this development effort for us. He's just exhausted because we're gonna start another set of activities next week as soon as this is over. MarkLogic World is over. He and the guys are going to roll back in, and we're going to start over on this this OCR exercise to see if we can tease out some incredibly high value data out of this image data for these rotors. So there's no shortage of opportunities, as I'm sure any of you can identify with, and we are just really excited about the relationship that we have and what the future will hold for us, and looking forward to coming back and in a year and really proving that model-based, domain-based definitions for models for the users can actually work. I still think it can. We're seeing early success there, but it bears a lot of discussion on how we continue. So that's all we got, and we'll take questions. Yeah.
Do I need a microphone?
Oh, yes.
They're bringing one up.
Where's that hand? Oh.
Well, thanks for sharing. It's very impressive work. Earlier you mentioned that there's an issue to deal with a paper-based notebook as well as other paper documents. I'm just wondering, what's your advice or experience regarding not just digitize the document, but also try to add meaningful metadata or data enrichment on top of that?
Right. So one of the things I did not mention is that I kind of glossed over is that on this workflow interface, when you assign that data model here, so supposing for a mechanical test we have gauge length as one of the things that would normally be collected in a paper notebook, we dynamically generate data forms based on those data models so that the users don't have to do any work. Once they've defined the data model, they can either assign that data model to like an artifact that they upload to the system, they can stick it on a process, and then we also dynamically generate forms. So that would be my suggestion, is to find a way to take the data models and dynamically generate forms. I mean, there are a lot of content management systems that have been doing that for a long time. When we first started looking at it, it was actually Joomla was one of the first CMSs to do that about a half decade ago, was to be able to use XML templating to generate dynamic forms. We're not doing that based on the data models that we're storing in MarkLogic.
Another question about the simulation data. So you mentioned the simulation data can be very large, easily terabytes. Do you also use MarkLogic to manage simulation data or other data?
We're gonna, yeah. So that's a really good point. Our pilot our goal is 100 terabytes of simulation data for our first round. But like I said before, people laugh at an exabyte in a month. That's nothing. So tiered storage probably is one of the things that we'll have to look at.
We'll talk about it.
But to that point, yes, the objective is to put that in MarkLogic, because one of the demands for our users, and we may, I don't know, maybe do a paper on this or something, or just come back next year and report on it. But I'm really insistent on doing this again next year, if you can't tell. Sweet. So yes, we want to keep it in MarkLogic, because what the users want to do, it's so crazy. They'll generate 100 terabytes of data off of, let's say, they'll seed the analysis with 10 gigs of data. They'll get, let's say 100 gigs out of that. What they want to be able to do is do feature analysis for that 100 gigs without having to rerun it every time. So MarkLogic can do that, right?
We'll talk about it.
Okay.
So the answer is it's going to depend on how the data is getting consumed, right? So where MarkLogic really excels is when people have very valuable data that they're looking for. So very few people are going to sit down and open up a UI and try to do a full text search to go pull out a scalar, right? Or some float value. That's not what it's really for. Can it do it? Sure. But is that the best value or the best use of the system? Probably not. So the question is really going to be how that 100 terabytes of data is actually organized. What kind of metadata that describes that information is already available, or what can we extract from it and build documents off of that to help guide search, right? It's entirely possible that we take a large chunk of that data, and I don't know how much it is. It's not that 100 terabytes is a problem. It's not. It's what really needs to be indexed, right? And so that's what the We Will Talk is going to be all about.
Well, they're not paying me to say this, but you know, the way that the community is doing it right now is that they're batch loading all the seed data in from Excel into MySQL, and then they're submitting that through their stored procedures up to the analytics platform, and they're all running it on their local laptop. It's scary. So I don't see the best path forward for sure for us is the capabilities that MarkLogic has in combination with our content management and workflow-based definitions. Because as I said before, because this is so abstract, this can be used to represent computational process as well. So having flexible processing and concept modeling is the starting point for what you're asking.
Anyone else?
You've stunned them to silence.
Yeah, just chew on it for a minute.
Really? I'm shocked. Okay. No other. All right then. Oh, okay.
Yeah.
It's okay.
Oh, sure. Yes. You already mentioned there's a dilemma between picking an existing ontology versus handcraft some of our own triples or relationships, and you seem to go after the second route. What do you think in terms of maybe down the street there will be interoperability issues, such as when you work with other parties?
Yeah, so we've actually, one really good example is there's an ontology for managing atomic first principles, like it's called QUDT, and we've implemented QUDT. Again, because we're using a flexible data model, we can accommodate really any ontology, either expressed in JSON or XML. It doesn't matter. So yeah, what we're hoping for is that because we're not the only ones doing this like additive work that's going on all over the country, that we will seed our own local ontologies. And I don't see any barriers to accepting other model-based definitions. In fact, that's what we're hoping for. When we start a contract with University of Texas at Austin and they do a year's worth of additive manufacturing, that at the end of the project, not only will they give us the resultant data for the fabrication and characterization processes, we will also get those schemas and data models, the ontology, if you will, from them that they use to drive that process. That's absolutely right. That's all. See, I told you. Just needed a couple minutes.
I saw you had images in one of your various data types. Can you talk about how you index those and how you characterize them so that they're accessible?
Well, so you start with the OCR bit on Rotor data, and then I'll add something else.
Okay, so it depends on which images you were talking about. Images by themselves, the answer in MarkLogic's universe is always to take it as binary, store it, rip any sort of file metadata off of it, or use any other context we can glean from other sources to build metadata for it, so people can search it and find it. We certainly aren't indexing the binary of the image in any sort of searchable way. On the scanned documents that were coming out of the Rotor data drawers that Matt was talking about, that's a different animal. So we actually have a partner that's doing the OCR work for us, and then they're going to be feeding us JSON data, and then that just flows into MarkLogic. We're going to store and index that and set up some facets based upon the structure of those documents.
I was thinking more of things like photomicrographs. It looks like you had some icons of those up front, things that don't have any text in them.
Yeah, so one of the things
that
we're doing feature vector histograms to create a histogram of the elements in that image, and then that's what we would index. So that as the users either add more or compare, I've seen it done. It's actually extremely effective for us to be able to take and do an overlay of those histograms for likeness of the contents of the images based on grayscale and other attributes.
Are you storing the binaries in MarkLogic or outside of MarkLogic? The search is based on metadata?
Yeah, so we're storing all of the file data, the object data in on-prem instance of Amazon's S3. We're using ECS.
You're storing on S3.
Yep.
So if someone wants to search the content inside that, you're not using full text, or is there any other system built on it? Full text search of the binary.
So, those files would all be fully described and have data models associated with them. So it would be as simple as retrieving the appropriate URI and then going and grabbing that file, if I understand your question.
I mean, like something inside that content, that binary, you want to search for it. How would you do that?
Right. So like I said earlier, so in the case of like a micrograph, we would build a feature vector histogram, and then we would store that, the data for that in MarkLogic, because that would be searchable, the attributes of that image. And then as the user would search for that, we'd be able to retrieve it and perform likeness for other close matches.
Okay, thank you.
So first of all, thanks. This is a great presentation. So
Super.
Brent was okay too.
Yeah.
I'm just trying to get on your.
The worst.
You talked about all the frustrating. You talked about a lot of the frustrations with the users, the inefficiencies, the repeating the research. What did the actual program business case look like? What is being expected? How do you justify the investment, or how did you characterize that to justify the investment? And then, are there expected returns?
Yeah, that's a very good question. So as a cost center, especially as a federal cost center, no. But what I've tried to be proactive. Sorry.
There's the face palm. I'm not the only one.
We're trying. We're really trying. But I mean, so yeah, the way that we generally characterize it is efficiency. That's the biggest metric that we use. We observe. We can't, short of actually with stopwatches and watching the people do their work. What we've been able to determine, and we've confirmed this with Gartner and Forrester and everybody else, that at least in our community, they're going to spend 40 to 60% of their workload doing really unnecessary data management tasks. We've talked a lot about a more advanced use case where we're doing domain-based model definition and execution for complex use cases, but I guess I glossed over the fact that 90% of our wins involve just helping people not put data on hard drives and carry it down the hall. Right, so that's a huge efficiency that we get, and then what we do is slowly introduce them. Now we say, okay, now that we've gotten rid of your portable hard drive, now that you're actually pulling the data directly off the equipment, now we can teach you about how to create models to represent what's coming off that equipment, make it more searchable, and interrogate it in a much more efficient way. So as far as ROI, that is a very challenging and difficult and awkward question. But I typically go back and rely on efficiencies of operation for us. So we're targeting, our goal is to have the researchers spend no more than 15% of their time doing data management every day, and that's easy to then calculate. We're talking, for our lab alone, it's about $50 million a year back to research. Yep.
Anyone else? No? Okay, thank you, gentlemen. That was not only informative, but very entertaining. Thank you.